don't anticipate homework this week because midterms are next week. Okay, so you guys have got quizzes, those 2 quizzes that need to get done, and anything else for chapter 1. Something that you should be looking for to study for the midterm. I don't do midterm reviews. What I do is remind you of the tests that we've taken. We took a linear functions test. So if you're wanting to study, then you should look at the linear functions test. And we also took this test from 1.1 to 1.4. Those and the quizzes that you just took. That's what you want to look at for the midterm next week. All right, so those are the 2 tests and then the quizzes you just took. That's what you should be looking at to refresh your memory on linear functions and quadratics. That's what you've learned so far this year. 2 functions, linear and quadratic, x and x squared. I want to say a couple of things as I'm correcting homework. In their, let's put it this way. If the directions don't say to give so many decimal places, or if you're not graphing, you shouldn't be changing answers like this into decimals. The only time you use decimals is when it says, give me a decimal answer or you're graphing. That's important because you need to practice the skill of reducing square roots. So if you're always going to the calculator and doing a decimal, then you're losing out on the knowledge of reducing square roots and then reducing your entire fraction. So like on 1.7, you had to find the area of a rectangle. And so you said, okay, base times height, and the area is 40. Then you did your distributive property and did x squared plus 3x equals 40. And then putting all your terms on the same side of the equation. Now, when it's asking you on a word problem to find the value of x, if it's not telling you to use the quadratic function, then you don't have to use it. If they don't tell you the directions on how to do it, you don't have to do it how the whole worksheet says. Okay, most of the time on the word problems. That's why they break it up in sections, because they're looking for specific things from you. But when you get to the end, it's always applying what you know. So this was about completing the square. Completing the square can be difficult when b is an odd number, because you always have to half that one. So you end up with fractions. And, I didn't take off a lot if you got it wrong at the bottom, down to the end. I didn't mark it wrong. I gave you as much credit as I could. But honestly, the first thing you should always do when you're trying to solve is what? What's your first technique? Yes, you should always, because when we get to chapter 2, it's a lot of factoring. So you got to have good skills at factoring. You were just introduced to it in this chapter, but we have to use it for the rest of the school year. So you should always try factoring first. X times x would be x squared. And then what are factors of 40 that would add to 3 if it factors? 8 and -5. Boom. See how easy that was? Think about completing the square that you did on this assignment. How long and drawn out it was, and you struggled and you didn't even get the answer because the b term was going to be a fraction when you divided by 2 and squared it. Had some problems working with fractions. Okay, so I just want to remind you that on both of these problems here, you could have used factoring very easy to get to the answer. I need one. Which one of these is going to be my answer? I have x plus 8 times x minus 5. Which one is my answer? 5. X equals -8. Can't use it because it's negative. So my only answer would be x equals 5 because the sides of a figure can't be negative. Okay, so remember that factoring is the best way to go. So here's our first problem that we're going to solve. So I'm going to stop at this point right here because of the square root of 1/2. I know that I can't have a square root in the denominator for my final answer. This would be the square root of 1 over the square root of 2 if I split it up. So before I even go any further, I just think to myself, this is all into the radicand. What could I multiply to my denominator to make it work out as a perfect square? Very good. So I can multiply this by 2, but I need to remember that whatever I multiply to it, it still has to be the same thing. So I need to do 2 over 2. Now I have the square root of 2 over the square root of 4. And that square root of 4 is going to be a perfect square. Everybody does things a little bit differently, so you may not have thought about it at this point, but every time I see a square root, before I go any further, I'm like, you know what? I'm just going to do it right then and there. What can I multiply under the radicand that would make it work out perfectly? And I see the square root of 4 is going to be a 2. So I'm going to shift my 5 over, and I'm going to simplify that square root of 4 as well. So I get m equals -5 plus or minus the square root of 2 over 2. So check to make sure your conjugate is correct. We need the conjugate to -8 plus 5i, which is -8 minus 5i. We need to multiply the numerator and denominator by the conjugate of the denominator. Check your first step to see if you're on track. Did you multiply the numerator and denominator correctly? Here we go. Write in vertex form. B is an odd number. Practice using those fractions. Write in vertex form means complete the square. I showed you to put the constant on the other side of the equation. All right. So we know that to complete the square, we have to half the b term and square it, and we have to add it to both sides. So halving the b term would be half of 9 and squaring it. And I need to add that over here as well. Half of 9 squared. Now, you shouldn't be changing it to decimals because there's nothing here in the directions that say use decimals. You have to have the skill of working with fractions. So you're just going to square the 9 and you're going to square the 2. So we have x squared plus 9x plus 81/4. On the left-hand side, you're going to have to find a common denominator, right? That's how we add and subtract fractions. So the common denominator would be 4. And then 4 times 19, we get -76/4. So it's 81/4 minus 76/4. (81/4 minus 76/4), which is going to be 5/4. We get 5/4 for this side. And we usually factor the perfect square trinomial. I know that x times x is x squared. And maybe you've caught on to what the shortcut is here if you've done it a few times. What is the number that's going to go in both of the parentheses? It's this number every time. It's the half of b that goes in here. So it's plus 9/2 plus 9/2. So we can check to make sure it's going to work, right? 9/2 times 9/2 is 81/4. Well, what's 9 halves plus 9 halves? That's 18 halves, and half of 18 is 9. Right? If I add them together, I get 18 over 2, and 18 divided by 2 is 9. So it works. So I'm not sure if you guys are catching on that the half of B term is what goes in those parentheses every time. Did you know that? All right, so then we just set it up as x plus 9 halves squared equals 5/4. And then we go back to the directions and see what they want. Do they want me to solve it? Or do they want me to, no, they want to know what the vertex is. And it said write it in vertex form. So how do I finish writing this in vertex form? I'm going to shift the 5/4 over near it. So I get x plus 9 halves squared minus 5/4 equals 0. Now it's in x plus or x minus h k squared. Oh my gosh. X minus h squared plus k. That's vertex form. What's the vertex? What's the vertex though? I need hk. What is the hk for the vertex? Negative 9 halves and negative 5/4. There you go. There's the vertex. Is this a maximum or a minimum? That's right. So if I go back up here, it's a positive parabola. I know it's facing upwards, and that would have to be a minimum. Use the quadratic formula. So it just says use the quadratic formula to solve. That's it. That's a final answer. Unless the square, oh, actually, it's one more thing. We have x equals negative 5 plus or minus the square root of 23i over 6. There's nothing that can be simplified from all three terms. The square root does not reduce. So I would leave it like that. Even if it didn't have I in it, I would leave it. If it just says use the quadratic formula to solve, that would be it. Unless it says round answers 2 decimal places. That's when you know they want you to do it. But if it doesn't say that and you're not graphing, you don't change it. You guys are good on the quadratic formula? What does the discriminant tell us about this if I was going to graph it? What's the discriminant? What is the discriminant? So the discriminant is negative 23. And Emily, what did you say it said about the solutions? 2 imaginary. Perfect. It has a negative, it's imaginary, so that would be 2 imaginary solutions, which means it's being graphed above. Which way is it facing? It's facing upwards, so it would have to be up on top somewheres where it's not going to cross. It couldn't be down bottom, because then it would cross. All right, graph. 12 is less than or equal to x squared minus 7x. So if it doesn't factor, I'm not going to complete the square. That leaves the first technique that we ever learned. X equals negative b over 2a. That's not a pretty one. 7 halves. So I'm showing my algebra. Now I want the vertex f of 7 halves. And if I want a fraction answer, because I think it's going to be a fraction answer, you can get a fraction answer on your calculator. You would go to math and tag on the first one, number 1. It says that you want a fraction answer. So when I hit enter, it says negative 97/4. There's my AOS, x equals 7/2. This will be -12 where it's crossing through. And my vertex is down here at -97/4. And then I'll use symmetry. 1, 2, 3. Well, that's not right. That's 3.5, so half. 1, 2, 3. Are we done this problem?
Yes.
We are? What's wrong? You got a shade because it says, what does it say actually? So I substituted in y for 0 so that I could actually gather my thoughts about what it does say. It says that y is less than the parabola. That's why I like to know where my y is. Y is less than the parabola. So that would be shading this region. Okay, let's go with this one. See how you guys are at simplifying square roots. Simplify the square root of 80. Simplify the square root of 80. So how did you do it?
I did a little
Upside down repeated division?
thing, and then I just kept dividing by 2.
Okay, so you did the repeated division. Yep. 80. Half it. Half it again. Half it again. So I see I have a 4 times 4. There's 2 perfect squares right there. So the square root of 80 can be broken up into, that would be 16 times 5. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. That's the perfect square in there. 4 square roots of 5.
Oh, I did it.
Stop erasing your answers because you think you're wrong. That's right. So I could actually have 4. I could put them under the same radicand. You said 3 times 2 for that one. You said 4 times 2 for that one. That helps me to see some perfect squares that are in there.
I have broken so
It's like, why put it back together to be 48 so that you can just take it back apart again? Right? Just, it's already broken down for you, so keep breaking it down. Is there any other perfect squares other than this one in there? Here's a perfect. Exactly. So I would rewrite that as 4 square roots of 3 times, what is that? That's going to be 16, right? 4 and 4.
So 8 square root of 3.
So what is the square root of 16? 4. So when I bring it out front, it's 4 times the 4 out there.
16 square root of 3.
Just wanted to refresh your memory on that. All right, here we go. So the midterm has 2 parts, okay? The midterm has a written part, okay? Calculator, no calculator. It's not going to be in depth and all that, but I'm just testing some skills here. So there'll be a part no calculator, a part calculator, and then the third part that you may or may not get done in class that you want to start now to think about is that you need to take a picture of a positive parabola and a negative parabola because we need to go to Desmos and we need to put them in Desmos like we did for linear functions. Okay, remember that?
So like an object.
Anything, yep. Any object that would be a parabola facing upwards and downwards. That's going to be part of your midterm grade. Okay, remember we went to Desmos and we did positive, negative, undefined lines. We did parallel and perpendicular lines, right? We did a linear regression so far in there. So we're going to go to Desmos and you are going to upload a picture of a parabola facing upwards and downwards. And you're going to put it on your digital ISN. Okay, those are 2 places that we've been putting those pictures. Yes.